This is year 12, 2015, algebra paper. Let's have a look at question 1. Logarithm definitely is one of the questions will pop out very often. And for this paper, the address is really on definition of log. We understand if we do have an exponential equation, and we can turn it into a log form, right? So log A of B equals X. Okay, let's have a look at this. It says find the value of log base 2 to base 2 of 1024. So it's really saying is that's equals to what, right? Then we can turn that into exponential form. 2 to the power of x equals to 1024. Now we know 1024 is 2 to the power of 10. Hence, if you have two things equal, they have the same base, they must have the same power. This is one way to think of it. Hence, x equals to 10. Okay, the other way to deal with this is one of the log property. Okay, if you have a log a to the power of n, that's equals to n times log a. Basically, if you raise the number to a power, and it's power, you're going to multiply the power there, right? Since log is really talking about power. Okay, so this is quite essential for using this. Let's have a look. And so if we use the second statement over here, we can turn log base 2 of 1024 into log base 2. Now, since 1024 is 2 to the power of 10, right? That's equals to, you can drop that in to the front, which is 10 times log base 2 of 2. Now, when you see log base 2 of 2, that says you raise 2 to what power give you 2? Obviously, that's equals to 1. Hence, the answer is equals to 10. Right, second question over here, same story. 4 is the base, so base raised to the power of 2 equals to 3w plus 1, and then 4 to the power of 2 is 16. Hence, you just solve the equation. So 15 equals to 3w, and w equals to 5. Okay, so that's answer. Question number 3. Same story. We can turn that log form into exponential form. So base is x, x to the power of 2. So x raised to the power of 2 equals to that, right? Equals to 4x plus 12. And if we want to solve a quadratic equation, we'll move everything to one side and then leave the other side 0. And then you can factorize. Right, so x and x, two numbers timed together equals negative 12, add together equals negative 4. So that's negative 6 and plus 12, x equals 6 or negative 12. Okay, based on definition of log, if you have base, something that equals to x, alright, doesn't matter the variable, so base b, log base b of a equals to x. Based on the definition, both the base and the a, 0, right, must be bigger than 0. Okay, that's based on definition. Therefore, x has to be bigger than 0, so that x equals 6 because x is the base here. Alright, we're going to scan through, have a look in question 2a. Okay, factorizing, or should I say simplifying fractions. Okay, or well, when you're talking about simplifying fractions, you have to look for factors before you can cancel out anything, right? Just like 2/4 is 2 over 2 times 2. That you can see that you can simplify that. That's become a half. Okay, looking for the common factors from numerator and denominator. So factorize the top. So we're going to do it separately over here. 2x squared plus 7x minus 4, and double up. So this is 2 there, sorry, 2x and 2x. Two numbers times together equals to a times c, so it's -8. Add together equals 7, so that'll be 7 and -1. Okay, positive 8. Sorry, 8 and -1. 8 and -1. And you can see there's a factor of 2, so you can simplify this side. And that should be equals to 2x divided by 2 as x and plus 4, and then 2x minus 1, right? That's the top one. Now for the bottom one is 2x squared minus 32. So we can see there is a common number, which is 2 and 32. That's 2 is outside. And then you have x squared minus 16. Right, if you can see that's actually a difference of two squares, that's actually equals to 2 times x plus 4 and x minus 4. Okay, you can verify if you expand this, you have x squared minus 4x plus 4x, that's cancelled out, and positive 4 times -4 give you -16. Right. Now we're going to actually write this as a fraction form, so x plus 4 and 2x minus 1, that's the top, and divide by 2 times x plus 4 and x minus 4, right? And you can see that's a common factor, x plus 4, that can be cancelled out. This one thing actually wasn't really mentioned during the lesson is we do understand the denominator can never be equal to 0, it's undefined. So, but we cancelled out x plus 4, okay, which you reduced the constraint somehow, right? Because previously, based on this, this is denominator, x cannot be equals to -4. But since you cancel out, x now can be -4, so be careful. I recommend you write down x cannot be equals to -4 because you simplify that, right? Okay. Question number B. So we have a equals to sums of the expression of y and find expression for a to the power of 7. Right, a, that's y to the power of 3/4. Right, we after the whole thing raised to the power of 7. What's going to be? Of course, you just raise the whole thing to 7. So that's y power of power multiply power 21/4. Okay. All right, question C. Let's ask the question over here. Okay. So far, actually, for the methods we have, we can solve quadratic equations. Okay, we haven't done anything to do with cubics or cubic equations because it's not as common. Quadratic equations, there are lots of methods, and so we always focus on quadratic equations. Particularly for assessment, you might see different forms. It might have a building structure as a quadratic equation, but for this is one of the examples, right? Now you can see, rather than actually have, for example, 2x squared, I'm just writing this down in a way that you can sort of observe what's going on, right? Rather than actually have x squared, we have, if I can highlight this without changing this, we have u to the power of third, and to u to the power of third, and but there is 2/3 here, right? Okay, 2/3. Basically, 2/3 is 2 times as a third. And just like over here, 2 is 2 times as the 1 there. Alright, that's basically the structure of quadratic. Okay. So if I rewrite this slightly, you'll see that u to the power of third there, right? And the whole thing raised to the power of 2. That's give you 2/3, right? Plus 7 u to the power of third. That's equals to. Okay, that's definitely a quadratic. So if we somehow replace this u to the power third as a single variable, you just say, right, let's a equals to u to the power third there, and you can see that's really a quadratic equation there. Okay, by moving everything to one side and the other side 0, we can use double up. So divide by 2, so 2a and 2a. And we're looking for two numbers times together equals to a times c. Let's give it -8. Add together equals 7. Seems like we use it quite often for previous question as well. So that will be 8 and -1. So +8 -1. And then whole thing that's equals to 0. Right. And you can see you can simplify that, and both 2 and 8 are multiple of 2. So we can actually divide this way. And we'll have a plus 4. And you have 2a minus 1 equals 0. And for this, a is equals to -4. For this one, a is equals to a half. Right. Hold on, it's not finished yet because we don't really have a, we have u. We want to solve what u is. But based on what we assume, we'll define a equals to u to the power of third. Right. Based on these two equations, these two solutions, we should be able to figure out what is u going to be. Let me just use the space if I can. Alright, so the first one is a equals to -4. Okay, which is u to the power third equals to -4. How to get rid of the power third there? Yeah, the reverse of third is really, or we can say the reverse of third root. Okay, is really the whole thing raised to the power 3. And then you have u, because power times power, power of power, you multiply the power. 3 times the third, you give you 1. So u is equals to -64. And the other one, u to the power third equals to half. And also you're going to cube both sides. U is equals to 1/8. Alright. Question 3. Okay, a negative index just means you change the sign, cross a line. We're going to cross a line first, and we have 4a to the power 5, that cross a line, and a to the power 10, that cross a line, the whole thing to the power 2. And then that 2 has to apply to everything inside the bracket. 4 to the power 2, 16. A to the power 5 to the power 2, power of power, you multiply the power, right? And then the bottom is an a to the 10 to the power 2, and that's 20. And then you can see there's something you can simplify. When you divide two numbers, if they have the same base, you basically minus the power, right? So 16, a to the power of -10, sorry, -10. And then you understand, you change the sign, cross the line. So we do want positive index, which is mentioned over here. Okay, next one. So, okay, a fifth root basically is saying is you raise that whole thing to about 3, and then the whole thing raised to the power of fifth, right? Fifth. When I say fractional index, it means you take a certain root. Okay. And in the class, probably I rushed a little bit, but let's actually simplify that because you have fifth over there. Okay. So let me actually simplify that. Basically, it's 32 divided by so over 5 to the power of, over x to the power 5, and then you have power of power, you basically multiply the power, right? Multiply the power. Okay. Now obviously when you have fifth there, it just means you take fifth root, right? So what we're going to do is we're going to take fifth root of everything over here inside. The reason is I can see 32 is really 2 to the power of 5. Okay. Now, if I can see 2 to the power of 5, 5 to the power of 5, excellent. That's, yeah, well, we don't really have to do the fifth root there. I can actually take that power, apply to everything inside, and that you can see the answer. So basically 2 to the power of 5, and to the power of 3/5 there, of x to the power of 5 raised to the power of 3/5, and then you can see that's simplified. And multiply the power, you got 3 there, and multiply the power, you have 5 times 3/5, that's x to the power of 3. That's it. Alright, thank you.